Good morning, everyone. So today I will teach about DBSCAN, density-based clustering in machine learning. Introduction, interactional feature clustering algorithms such as k-means require the number of clusters to be predefined and perform poor when data contains noise or clusters of irregular shape. In real world, dataset often contain noise and clusters that are uh, in shape means not just spherical or uniform in density. DBSCAN was introduced to solve this issue by detecting cluster based on data points density rather than predefined assumptions. It is widely used in fields like geographic data analysis, anomaly detection in network traffic, and social network analysis. For example, a dataset contain geographical location of restaurants in city can contain dense restaurant areas and isolated, you know, isolated points like uh, DBs can effectively clusters dense regions. We will make sparse isolated point as noise. So next one is concept description. Description. DBSCAN is an unsupervised density-based cluster algorithm. It categorizes data point into three main types based on the force density. 4 point border point, noise point. These are three types of three categories. In first category, core point, data point is considered a core point if there are areas list mean point, other point with an epsilon radius. Second is another border point, a point that lies within a epsilon both of core point, but they favor their mean point in the own neighbors. Another third category is noise point. The another name is that outlier, a point that is neither core nor border and does not belong to any cluster. Example of this: consider a spatial data of city, restaurant, location, latitude and longitude. DBSCAN group restaurants is densely populated areas into cluster and make isolated coordinates as noise. Working mechanism of DBSCAN. The algorithm work in the following step: pick any unsupervised point, P point, find all point in neighbors with distance. If the number of points in the points in the neighbors is less than equal to mean point, make P as a core point and start a new cluster. Expand the cluster by recursively visit all neighbors of core point. Points that do not meet the mean point condition are marked as a noise point cluster. Repeated until all points are visited. For example, I will explain in through code for each point P in dataset P. If P is not visited, make P as a visit. If there is a use if then condition, means P is visited, then P as a marked visited. Link point is region query P. If size core point is less than min point, mark P as noise. Is create new cluster C. Expand cluster P link point C min point and solution. So another challenges are limited parameter sensitivity. First, choosing the right values for epsilon and midpoint is critical. Poor choice result in wrong cluster or misdefinition de- definition of noise. Varying density clusters. DBSCAN fails when the dataset contains clusters with highly varying density. Because of fixed epsilon does not suit all clusters. High dimensional data. The concept of the tests become less useful in higher dimensional space. Poor for result, computational complexity. The time complexity is of n raised to 2 unless special indexing structure like KD tree are used. For example, if one cluster is dense and another spare using fixed epsilon cloud merge distance cluster some another some together altogether alternative solution like ordering point to identify a cluster solution varying density is better. So last point is a summary. Summary. Davis can automatically discover cluster without needing the number of cluster to be predefined. It expectly detect outlier means noise will suit for detecting actively shaped clusters in noise. Spatial data required a careful parameter tuning, epsilon and midpoint used in application like geographical point and interested cluster network atomic density detection and bioinformatics. Future application extension such as optics improve handling of clusters with varying density, especially helpful in real world application like urban planning, flood detection, and ecological data analysis. Thank you.